Okay, welcome everybody. The new section, which is called Telecommunication Engineering. My name is István Balajti, and I'm Associated Professor for Debrecen University. And I'm basically engineer electric, but for the last 5 years, I changed my profession for the mechatronic engineering courses. My military background give me, I am a radar engineer, and for the last 40-something years, I work with the radars, radio reconnaissance systems, digital signal processing. And my PhD came from the digital signal processing about 40 years ago. That time it was something new. Today it's a piece of cake, but the original stuff would not change at all, Only much more compact, and you can make a lot of stuff. So today, basically, we have, some nice presentation. First, we have, Martins from Latvia. He is here. Martin, where are you? It is here, Okay. The second one is from Iraq, Noora Salim. She's online, no? Okay, it's very fast, Georgi, Lyubomirov from Bulgaria. Are you here?
That's right. I'm happy to attend online. Sorry, I have commitment, and you see that the whiteboard is behind my back. So after that, I will have students, but I hope that you will hear me well, and we'll try to present the maritime industry challenges concerning communications.
Yeah, perfect. The voice is good, the photo of yours is also good. The whiteboard, it's professional. You really looks like as a professor,
Thank you.
I give you, the word, and the ball is yours, Let's start it.
So the others are not present, right? Or I can't hear you. Sorry, I can't hear you.
Okay. The issue is, there is the lunchtime still, and they are somewhere lost in between the road, the lunch, and the conference room.
Okay, so it's my turn.
Yes.
Thank you. Thank you for this opportunity. I will share my screen, and let's see. Do you see my screen? Hello?
Yes. I've seen it perfect.
Okay. So let me introduce myself. I'm Associate Professor Georgi Dimitrov. I'm from Bulgaria, from Varna Nikolai Vaptsarov Naval Academy. I'm a teacher in mobile communications and also global maritime distress and safety system. I would like to make a presentation how we can enhance maritime communication security using blockchain technology. I'm together with my co-author, who is currently on a voyage, and he was not able to attend, but he is Captain Third Rank Ivaylo Mitishev, who is a programmer and a PhD student. So I will start with some maritime industry challenges. Maritime communications involve complex interactions among shipping companies, port authorities, regulatory bodies, different stakeholders, and these interactions span different processes, which are cargo tracking, vessel management, also different compliance checks, financial settlements, and the communications on board confront with many limitations. Maybe this is the first of all, the trust deficits, data integrity, operational delays, and what we would like to suggest in our solution is to test in our future work a centralized communication channel, decentralized communication channel, because the inherited systems are centralized and they lack transparency and also lack of trust among participants. So you see that the communications are still using radio waves on medium frequency, on high frequency. Of course, they are getting obsolete, but still in operation. The main communications are via satellite, but you have application service providers, vessel traffic services, also port operators, VHF, digital exchange system, etc., etc. So, talking about our solution, the blockchain can be used to transform the current maritime industry communication system, because normally nowadays there are operational inefficiencies which arise from the process of manual verifications, paperwork. The systems could be outdated, and what is resulted in fact is delay and overall inefficiency. That's why if we have enhanced data integrity and trust, then the communications will be much more reliable and likely for the 21st century. So one of the defining characteristics of blockchain is the immutability. We are all aware how blockchain works. It is not obsolete, and it could be utilized with success. So once data is recorded on the blockchain, it cannot be altered or deleted. And this is crucial for the maritime communications, where you have the integrity of data important. The communication logs that are related to ship routes, cargo manifests, also identity records of crew members are permanently fixed if we utilize blockchain. This immutability ensures that all recorded information could be tamper-proof, and this would bring a higher level of trust among stakeholders. The blockchain technology introduces a high degree of transparency. All participants can verify records, and every authorized participant in the blockchain network can view and verify communication records. So the key concepts in blockchain are to have a smart contract, what we envisage. For example, if smart contracts, which are self-executing contracts, are converted into lines of code, they automatically execute, verify, and enforce this procedure once if the certain conditions are met. There is a platform which is known as Ethereum, and it is one of the most well-known platforms to support smart contracts that enable such decentralized applications that can operate without the need for intermediaries. So if we utilize blockchain in maritime communications. The stakeholders, first of all, may resist adoption of such a new technology due to concerns that regard the management and if there is conflict of interest, there could be a problem. So the targeted educational campaigns could have the benefits of blockchain technology and dispel these misconceptions. If there are pilot projects initiated, it would be possible to demonstrate the practical benefits and feasibility of blockchain solutions in real world maritime scenarios. So what is envisaged is to have cargo tracking, secure communication logs and compliance checks, automated payment settlements, and tamper-proof records. So what is the proposed network? First, if you take a look on the slide at the right side, there is a smart contract creation. The smart contract is a self-executing program that is deployed on a blockchain network. So it is designed specifically for managing payment settlements related to cargo delivery. Then you have a trigger of events, which means that the smart contract could monitor two critical events: cargo delivery and compliance verification. When the cargo reaches the destination or the designated port, the smart contract receives a signal indicating successful delivery. And if the smart contract verifies compliance with predefined conditions, then these triggers will say that it is compliant, and you will have as a result when the payment should be released. And after that, you have a possibility for automated payment release. Upon successful cargo delivery and compliance verification, the following occurs: the smart contract automatically executes the payment release process. Funds are transferred from the payer's account to the payee, which is the cargo owner or the supplier, and this automation eliminates manual intervention, and there is reduction of administrative tasks. If we implement a blockchain algorithm for maritime communications, there is an option that first you have every generated block that undergoes verification. So the verification is the proof of stake mechanism, and the participants validate the accuracy of the transaction. Once the consensus is reached, then the block is verified and it is appended to the existing blockchain. One of the pivotal benefits in the maritime communication is the real-time tracking of goods. Opening the algorithm, first, the first block is the genesis block in the blockchain, let's say 1, 2, 3, 4, 5. And it is the starting point from which every subsequent block in the chain emerges. So the genesis block is hard-coded into the blockchain protocol and contains unique characteristics that distinguish it from the other blocks. If we take a look at the stages and the entities involved, first, this is the shipping company that issues the bill of lading and manages the cargo. Then the Port Authority manages port operations and cargo loading and unloading. The customs process and clear the cargo through the customs services. The transporting operator handles the transportation of the cargo. The recipient receives the cargo at the destination. The verifier verifies the authenticity and if the bill of lading is correct. And the final recipient confirms that everything is fine and the block in the blockchain represents a stage in the process that ensures transparency and security throughout the shipping process. What is envisaged in the near future is to do some experiments with Amos Connect. Amos Connect is well known in the maritime industry as one of the best, let's say, applications, and using Python-based prototype, it is possible to include it in such a platform. On the next slide, I show structure how the code will look like. So you have the cargo identification, the status, and then function that will send the data to the blockchain API. The nice thing is that you can have end-to-end encryption. Also, if you utilize VPN, then nothing can be compromised. And in this mechanism, there are data integrity checks and audit mechanisms. The key takeaways that the integration of blockchain technology into maritime communication systems could be a significant advancement that will provide for better security and efficiency. But there will be months of experimental work. One promising area of research involves the development and testing of such smart contracts that can automate complex maritime transactions, such as real-time cargo tracking and the autonomous vessel operation. This was what I wanted to present. This is Nikola Vaptsarov Naval Academy with a nice view of Black Sea. Greetings from Bulgaria and warmest regards. Thank you for your attention.
Dimitri, thank you so much for your marvelous presentation. We really enjoy it very much. I hope we have a few questions from the audience. Somebody have some question, please? Okay.
I have some questions about the design choice of the blockchain. As you mentioned, you chose to make it fully transparent for increasing the trust. What do you think can be the drawbacks, the potential problems with it? Because if it's transparent and we are transporting, let's say, some strategic goods, wouldn't it have a problem with literal piracy or people trying to intercept, as everyone can have access to it? Or it's not total transparency?
No, there will be no total transparency because there are actually interested stakeholders and parties. And there was also, thank you very much for that question, because last week there was a conference here in Varna, and there was a solution utilizing generative artificial intelligence that would like to cope with these data privacy concerns. So actually, it would be an upgrade of the platform that Amos is offering to the maritime business. So I hope that they will not mind our experiments, since we would like to test it live using their satellite hub and the applications that are already on board on a real ship. We have a research vessel that has such a communication application, and the test will be real on that satellite communication channel.
Great, thank you.
Thank you. Yes.
Somebody else? Do you have any further question? Maybe I can ask about, you mentioned that the near future tasks related to Internet of the Things, What do you mean? It's cloud or local one, or how is it?
Internet of Things is already utilized here in some parts of the port. What I mean is, for example, we did some experiments before the COVID times with small tracking devices. So in Varna, we have vessel traffic services, of course, in Burgas and other small ports, but the vessel traffic services cannot follow small leisure boats. They cannot track, like, for example, jets or fishing boats, etc. And we have installed a small tracker on a boat which uses a platform, and actually this is a device which is sold on AliExpress. Of course, it costs $10-12. It has GPS, humidity sensor, accelerator, and the battery after one charge lasts for 1 day and a half. So when you install it, it's small as a matchbox. So when you install it on such a leisure boat, or for example a small craft, you can see it on a map that is a part of the platform, because here in Varna we have gateways that process this data, and it is easy to help the vessel traffic services, especially during the season. So if you are interested, I can send you my publication, which was in a conference several years ago.
Please send a publication I'm interested in.
Okay, that would be fine.
Somebody else? Do you have any further question? If not, Professor, thank you very much for your presentation, and I hope you stay with us.
Yes, of course. Thank you very much.
Bye.
Bye.
Is there somebody on the queue? No, this one, but in the online. Yeah. Because this was the few years.
Yeah, from yesterday's session.
Okay. So the next presenter from yesterday, the Raspberry Pi-based hardware implementation of various neural models, and Vedat Burak from Turkey will present it.
Yes. Hello, everyone. Can you hear me?
Yes, we can hear you clearly, professionally. You have 15 minutes and also a few minutes more extra for question and answer. And Burak, the ball is yours. Please start your presentation.
Thank you so much. My name is Vedat. Normally, my presentation program was in another session, but some due to health reasons, I was changed to this group. I would like to thank here for those who provided me this opportunity. I am research assistant at Erciyes University in Turkey. In this presentation, I will explain the results of implementation of various neural models on Raspberry Pi. And the second, the comparison of the mathematical solution methods. And also the last part that I will explain, which mathematical solution method is suitable for the implementation of neurons and performance differences between them. I want to think of this work in three main parts. First part is neural models. Second part is mathematical realization methods or solution methods. And the third part is Raspberry Pi. I will describe our work under the three roofs. In this paper, we have selected 5 neuron models that are accepted in the literature. These models differ from each other in terms of the complexity, implementation cost, biological accuracy, membrane dynamics, and diversity. The first neuron model is Hodgkin-Huxley neuron model. Is very biological accurate. It is expresses in the ionic channels of the neuron, very detailed. However, it is quite complex model and the cost of implementation is really high. Morris-Lacker neuron model is also biologically accurate as Hodgkin-Huxley, but it is simpler. Since it involves hyperbolic function, it is against relatively difficult to implementation. Fitz-Nagumo neuron is a very simple model. It is have two differential equation. Fitz-Nagumo is a simplified version of the Hodgkin-Huxley neuron. Biological accuracy is really poor. It more mimics to behavior of the real neuron. The fourth one is Hindmarsh-Rose, like Fitz-Nagumo, has a mimetic structure, but membrane dynamics are richer than these three models. Since it contains three differential equations, it is relatively difficult to implement. István neuron has a simple structure. It is modeled with the largest membrane dynamics. István have more than 20 different neural dynamics. These models are well accepted in the literature and have been studied in areas such as chaotic, neural noise, neural resonance, synchronization, neural network, implementation, and some object recognition, etc. In order to solve differential equation in digital environment, a discretization process is required. The most preferred method here is the Euler method. Euler is a very simple model, but it's preferred in studies where spike timing is important rather than spike shapes in neural models, like learning or memory. However, to understand the details of the neuron, spike shapes are important. In this case, the Euler method is insufficient. Here, we see the fourth order Runge-Kutta and new version of the Runge-Kutta methods. These methods based on the Euler methods. In these methods, a step size is determined with we call the H and the next value is calculated in very small steps. These with the mathematical model in neural. We calculate the other dots with the time. In initial value K1 is calculated into the neuron models with the initial condition. Then K2 calculate the initial condition plus K1 and goes on to K4. With this equation, we use the K1, 2, 3, and 4. The next value of the neuron differential equation we are looking for is calculated. This is the second, the next value of the neuron model. When we look at the new version of this idea, the differences is that key 5 is calculated in more detail compared with the fourth order Runge-Kutta, which means that the realism of the model is increased, but the speed decreases compared with the fourth order Runge-Kutta. Unlike the Runge-Kutta methods, there are Adams-Bashforth and Adams-Moulton methods. Also, combined with two of them, Adams-Bashforth-Moulton method. Adams-Bashforth method, we need to know the first term. If we compare with this one, we know the just first term. But Adams-Bashforth, we need to first 4 terms. The next value is estimated according to these first 4 terms. It is important to determine the first 4 terms because it accelerates the convergence of the solution to accuracy. Adams-Moulton method corrects the known value with the previous term. Another method is need to in Adams-Moulton method because this method corrects the known one. For example, the results solve the Euler methods, but is corrected by the Moulton method. In this way, the error is reduced. A version of this idea is the Adams-Bashforth-Moulton method. The value for the next differential equation value is estimated with the Adams-Bashforth, and the estimated value is corrected with the Moulton method. It is obvious that the Moulton method is a slower model because we need to know the values in every steps. Accordingly, the Adams-Bashforth-Moulton method is also relatively slower. Okay, the third part is Raspberry Pi. Raspberry Pi is a mini computer. The size of this computer is credit card. It is used in various engineering fields with the ability to provide 4K display, fast interface with Wi-Fi, Bluetooth, or USB ports. We preferred model 4, Raspberry model 4B, with the different other models. It is highly controllable, stable structure, it is easy to reconfigure, it is less affected by the noise, and also big RAM or Ethernet capability. Raspberry Pi have also some general purpose input and outputs. It can be used both, this card used both engineering or hobby project. All outputs and inputs are digital, require a digital to analog converter circuits if we need to analog outputs, just like the neural models. After establishing the general framework, I would like to elaborate a bit more and share the results we have obtained. As you can see, Hodgkin-Huxley model is defined for differential equation, also some exponential formulation. With the high exponential expression, a large resource need to do digital implementation platform. Because of this complexity, implementation cost really high compared with the other neural models. Hodgkin-Huxley model was implementation on Raspberry Pi with 5 different mathematical solution methods. I want to give some parameters with the create the samples. And these two figures see the oscillation outputs with the oscilloscope. The section show the yellow one background is the method with lowest error. But blue background shows the method with the highest solution speeds. As you can see, Adams-Moll time is the most accurate method compared with the normalized root mean square error. But Adams-Bashforth method is high speed. The second model is Morris-Lecar. Morris-Lecar have 2 differential equations, but also have the hyperbolic function. It is a bit simpler than the Hodgkin-Huxley, but not the simplest of these 5 neural models. Also, you can see the totally different membrane dynamics. As you can see the amplitude with maximum is 40 millivolt and minus 50 millivolt. In this model, similar to Hodgkin-Huxley, the lowest error have Adams-Moll time, but the fastest model has fourth order Runge-Kutta. But it should be noted that there is a very little differences between the fourth order Runge-Kutta and Adams-Bashforth, because you can see the 1.38 and 30 this period, and fourth order Runge-Kutta 1.3805. It is too close to each other. Third one, Fitzhugh-Nagumo, it is simplest version of the neural models. 2 differential equation. I want to choose the stimuli current with the frequency forcing current, because I want to demonstrate the Raspberry Pi can show the complex inputs. Same as the other methods, the Adams-Bashforth is highest speed, high speed, have the high speed. Adams-Moll time have low error. And the Hindmarsh-Ross is a different type of the neural models. Among the dynamics of the Hindmarsh-Ross neural model, unlike the first 3 neurons, there is also a burst waveform. We call that this type of dynamics, we call that the burst, which is defined as the wave with the phase spikes, and after the long resting time, membrane dynamics show another phase spike. Hindmarsh-Ross and Raspberry Pi also show the chaotic behavior, this type of chaotic. It means that while spike shape is important for the learning memory, the burst waveform has been observed the human brain during the sleep. The burst waveform important for us. And the last neural model is Isakevich. Isakevich also easy to implement and really reach neuron dynamics. I want to show the different neuron dynamics, phase spike, for example, and another burst behavior. However, compared to the other models in this model, the data was measured more inaccurately in the subthreshold amplitude. This is the subthreshold amplitude. We think that this is directly related to structure of the neuron model, because all dynamics of the Isakevich neuron were measured incorrectly at the subthreshold level, but this is also the reason for the high error. Okay, I want to overview these slides. If we wanted to compare mathematical solution methods with an overview, we gave 5 points for the best results, and we give the 1 points for the worst results. First of all, we compare with the speed of the mathematical solution methods in these parts. Hodgkin-Huxley neural model, the fastest method is Adams-Bashford, but slowest method was Adams-Moulton, and Adams-Moulton also the worst speed for all neural models. In this way, we compare with the themselves and average of them. Here we saw that the fastest method was Adams-Bashford method, but fourth order Runge could also have good speed for the solution mathematical model. And when then scored the errors, with the largest error being 0.1 and the lowest error being 5 points. And we see that the spike waveform with the lowest error with the Adams-Moulton method. But we choose the burst waveform, Heitmann-Strauss and Isaacevich. As you can see, Adams-Moulton have a big error with this model, these dynamics. We can choose the fourth order Runge-Kutta for the burst dynamics. And these error values were obtained by recording oscilloscope data and compare with them the simulation data. If we compare overall with speed and error, we can say that the fourth order Runge-Kutta is best of the neural model implementation mathematical solution methods. The second one, and Adams-Bashford.
Sorry, Burak, it is 1 minute left for you.
Okay, just the last slide. Thank you so much. And this table, we can see the Raspberry Pi compare with the 5 mathematical models. Raspberry Pi to achieve the dynamics behavior of the neuron for 5 methods, and easy to design flexibility, but Adams-Moulton and Adams-Bashford model is really complicated. Simulation speed also is fast, the 3 of 1. And simulation accuracy with spikes, we need to choose Runge-Kutta version of Adams-Moulton. If we version of the burst, we can choose the Runge-Kutta, new version of Runge-Kutta and Adams-Bashford. Thank you so much for listening to me. If you have any question, I will be happy to answer.
Okay, thank you so much. Somebody has any question here? I also want to have one because our university uses a Raspberry Pi very frequently, you know. And I want to ask you about the operational system. You know? You use a 4 gigabyte memory. For us, the 4 gigabyte is usually not enough, you know. You have to install the system. After that, you have to use some programming languages to code, you know. So can you manage this 4 gig? Everything okay? What do you use? What the platform is above the hardware? What software platform do you use?
I use the 4 gigabyte RAM, but Raspberry Pi have some 8 gigabyte RAMs. And I also use the Python program, and these neural models doesn't have any big data. It is too good for the minimum hardware. Yeah, that's all.
Okay, in this case, thank you very much. Somebody else, any question further? No, thank you.
Thank you so much for.
Bye bye. Okay. Presenter is online or we have? No, we have here. Okay, good. So we have, you know, the presenter from Debrecen University. It is a Zsombor Lajos Osváth. He presents the educational issues of LiDAR sensor functioning and impact in the ADAS technology today. He one of our best students who is in the engineer electric and mechatronics department, student right now. And I hope next year he will serve, to be here again. And Zsombor, the ball is yours. Please start. You have 15 minutes and 3 minutes for question.
Okay, thank you so much for your introduction. Welcome everyone. My name is Zsombor from Debrecen. I'm a BSc student, and my topic I'm going to talk about is educational issues of LiDAR sensors functioning and impact in ADAS technology. So let me give a short outlook that I will talk about. Firstly, I will mention my motivation from educational point of view. Then I will talk about the advanced driver assistance system and then the LiDARs. After them, I will mention the data processing things, and after all, I will make a conclusion and mention my future directions. So for my motivation, the left side, you can see the key areas of LiDAR sensors, like self-driving vehicles, drones and robots, cartography and topography. So as you can see, it's such a colorful sensor. And under it, there are the main using fields of LiDAR sensor, like navigation and object recognition, 3D mapping, monitoring, and so on. And all of the each of these topics, like key areas and applicability, the first two of them are these that I'm mainly interested in. So actually, that's the reason why I wanted to research about ADAS technology. That is actually a significant challenge for the fourth and the fifth industrial revolution, because it also uses artificial intelligence and sensor fusion, and that's for make our daily life safer and more reliable, and make the data process as fast as it can, so make it real time. And let me mention the education points. After this conference, I will make a pilot project, and I want to investigate on applicability and efficiency, and also the personal motivations of the students. And yeah, I think one of the most important thing is the soundness of technical solutions, and yeah, I also want that to improve the project management skills. Okay, so why is ADAS important? ADAS, as I mentioned, is Advanced Driver Assistance System, uses 4 types of sensors, like radar, radio detection ranging LiDAR, light detection ranging camera and ultrasonic sensors, and has 6 different levels from 0 to 5. And level 0, there's no autonomy, so everything is manual. In level 1, there are some driver assistant like adaptive cruise control and lane keeping. Level 2, there are some partial driving automation like self parking systems. And at level 3, this is the level when the driver don't need to keep their eyes on the road continuously, but always have to be ready to take the control when there's some dangerous situation. At level 4, can talk about LiDAR taxis in Phoenix, Arizona. They are testing it for, I don't know, for a few years. It's almost fully autonomous, but in just limited conditions, so it cannot park indoor garages or cannot go to the highway. And at level 5, there's cars with full driving automation. There's the future, and there's the level when the cars will drive safer and reliable than humans. Okay, so what are the LiDAR's function in ADAS technology? First of all, the distance measurement used for ACC, anti-collision, and auto braking systems. Then the vehicle positioning and the lane keeping systems, the object recognition and tracking like pedestrian detection and sensing cars. And the last, the night vision, or actually the longer conditions to see its environment around the car. So the operational principle of LiDAR sensors, here is a LiDAR sensor in the grill, an Audi. So yeah, LiDAR is actually a type of radar sensor, but the wavelength is much shorter than the radars. It used in common around 500 to 1,000 nanometers wavelength. And in operating, it starts with the laser emission, then the lights reflects from the objects. The echo is received by a receiver diode, and from these data, we can calculate the distance with the following equation, and it's so easy because we know the speed of light, so it's not a challenge. Okay, so what types of the LiDARs have? We can separate them based on a scanning method. First, the mechanical scanning, like a rotating LiDAR. It emits vertically some laser beams. Then it reflects and then can measure the distance, and it's rotating around itself 360. Then the solid state LiDARs like micro electromechanical system and optical phase array. MEMS uses a rotating mirror, and it has a wider range of vertical axis than the rotating LiDAR, and that's the LiDAR what actually nowadays other cars uses. But the OPA LiDAR is actually the true solution of solid state LiDAR because emits from different emitters and in different ways the laser beams. And last, the flash LiDAR. This is actually project an image, and with one flash can 3D map the environment, but the distance should be shorter than 10 meters because it can damage human eyes, but it can penetrate through fog, so it can be used in foggy conditions. So the other way we can separate them based on dimensionality. There are 2, 3, and 4Ds. The difference between 2 and 3D is actually the number of the layers, because in 2D we use from 1 to 4 layers, but in 3D we use as you can see 64 or even 128 layers. And the difference between 3 and 4D is actually the velocity. So 4D has also 3 coordinates, but can calculate with velocity. And last but not least, we can separate them based on modulation techniques like time of flight, EMCV and FMCV. The time of flight is actually to emit laser pulses, and uses the equation I mentioned before. but AMCV and FMCV uses continuously waves in a specific pattern or frequency, and uses the difference, firstly the amplitude to calculate the distance, and the FMCV uses the difference between the frequency and from this it calculates the distance, and the FMCV will be probably the future's ADASCAR's sensor, because it can use 4D dimensionality without any GPS. Okay, so the multi-sensor integration in ADAS technology. Here you can see all of the sensors of an ADAS car, and the LiDAR is actually connected to the camera and the ultrasonic sensor. And the camera and the ultrasonic sensor are actually inactive, but when the LiDAR is give a signal to them, they will be active, and the LiDAR will deactivate itself. But when the camera or the ultrasonic sensor will deactivate, they will reactivate the LiDAR sensor. And when can we place these LiDARs in a car? Maybe in the grille, in the bumper, headlights, behind the windshield, or even on the top of the car. And as you can see, there are advantages, but also disadvantages from them. But the main integration challenges are cleaning, heat management, optics, and static. The heat management can be, so there can be a solution of ceramic packaging, and for the optics, it's the main goal is to avoid image deformation. Okay, so let's go to the data processing. There are the key steps of data processing, like segmentation, object recognition, classification, object tracking, and so on. And under these key steps, there are the methods can be used to make this to make these steps. And I mentioned Kalman filter twice, here in object tracking and here in sensor fusion. So I will talk about it now. So okay, for the Kalman filter is actually used to estimating the state of the dynamic system using time varying measurements, and also can be a solution for linear quadratic estimation problems, because it can calculate with system noises and measurement errors. And the two main steps it uses is time update and measurement update. Time update is to predict or make a prediction. It's for estimating based on the current state and the system model. And the measurement update is about correction to estimate based on updating. It uses new measurement data and use it in time or in real time. And these two main steps actually follows each other in a circular manner. So let me mention my future work. After this conference, I want to research even more about LiDARs, like operational efficiency and cost reduction, as the ADAS car maybe standardize the LiDARs in ADAS cars, or the multi-sensor integration. How can it be even better than now? Or is there any future safety requirements there? And maybe I will research about some data processing topics. And yeah, for the education, I think education should investigate even more to AI supporting or AI supporting engineering because I think it's really important to use AI nowadays, even in the education, not only factories, and to extend engineering project management. So yeah, I think others should be a significant R&D direction in the near future to save human lives and manage disaster situations, because nothing can be more important nowadays and in the future that getting from point A to point B safe and sound. And for the findings and takeaway, as I mentioned before, I will create a pilot project for growth of education efficiency. And my goal is to investigate on applicability, efficiency, and achieved it by my personal motivation. And my endeavor also is to guarantee the soundness of the technical solutions, and also to improve not just myself, but also all students who is studying engineering. Thank you for your attention, and if you have any questions, please ask me.
Thank you so much. The presentation really was good. You know, I enjoy it very much. Is there somebody who has some question about the other system, the LiDAR system or radar system? The radar is better to me.
Just really very nice presentation. Yes,
Thank you so much.
just a short question. What do you think will we ever reach or come to the 5th level?
When will you reach it?
Yes,
Uh,
because the progress is ever slowly. So the accelerated. Yes.
yeah.
We are on the level 3 already for 10 years.
Yeah. Well, actually, I think because of the AI is just come for everyone just 2 years ago, I think. I think we can reach it around 10 or 15 years, like prototypes. But if the time when in our daily lives are in level 4 technologies, I think it should be around 30 years to everyone is okay with it.
Okay, thank you. And just another one short question, because of receiving part of the LiDAR.
Yeah.
So you know there are many in many countries there is allowed to install in the car radar warning systems. For you know what I mean, for warning before the radars for measuring the speed of the car.
So
Yeah, but
so what?
Yes. And the question is if
sorry. Okay, sorry.
I just check if you understand my
Okay.
mean. Yes. Is it possible to use receiving part of the LiDAR, this conventional LiDAR in cars, for radar warning systems?
Actually, these cars uses these to measure the distance, so to communicate the camera and the ultrasonic sensors. So actually the radar is to measure the speed and these things. The LiDAR is only to freely to map its environment and give signals to the camera and sensors. So
I just would like
it's
to
a
ask.
warning. It's about that there is a leader that's coming, speed limit and any other.
Yes, this was. Yes,
It is nothing to do with the safety.
it is the opposite of the safety. Yes, but I'm just asking. Is it-
Okay.
Yes. But these systems are allowed in many countries, therefore, so I did.
Yeah.
Okay, thank you, thank you, thank you.
You know, yes, thank you very much. It really was a good question, you know. And yeah, you are right, you know, that the problem is to the warning, you like a radar receiver, you know. The police started to check, you know, to the speed limit. And I already have seen what was sitting one of the car, you know, which has full bunch of LiDAR, radar, all kind of stuff, you know, which shows the driver to, hey, be careful because it will cause you for life. But anyhow, I think, you know, this presentation was very good, you know, and I hope you will continue your scientific career in the future. I trust you, and I ask everybody here to applaud again, you know. Let's see who is the next one. You? Okay. You are from?
From Turkey. The next presentation is mine.
Yeah. In this case, come here.
Yes.
The few people are missing here, you know, and I want to know the deep learning.
Yes.
Okay, good, you know. So the next presentation for Mustafa Omar, Ligere from
Yes.
Turkey, and the next presentation from Mustafa Omar, Ligere from Turkey, a deep learning application for Dolph-Tschebyscheff antenna array optimization. This is one of my favorite subject, and I'm really interested in how can you manage it, you know, because the Dolph-Tschebyscheff filter itself is, and we know the antenna is a space-time filter, one of the most efficient one.
Yes.
And if you could manage it efficiently, you are one of the best.
Thank you.
Okay, Mustafa, you can start, you know, you have 50 minutes, and after that you also have 3, 4, 5 minutes or even more for question. Thank you.
Thank you. Yes. But there's Lithuanian, I think. Here is English.
You have Kuchuk problem.
Yes.
Check your phone. The second presenter also, yeah, with you. It's already uploaded.
Sorry because of this. Yes. My name is Mustafa Önerdikdere. I am from Turkey. I am PhD student at Gazi University. I am working in TürkSat satellite services in Turkey. Here is our work about a deep learning Dolph-Tschebyscheff application for antenna array optimization. Here is the abstract of our paper. I produce this abstract in the slides. Antenna arrays are key elements in communication systems, and they offer the ability to direct radio frequency energy in specific directions with high efficiency. With the increase of wireless devices, new techniques seek to design them for several requirements, and novel techniques and novel integrated algorithm models are available for designing antennas. And in our paper, we present a novel approach where genetic algorithm outputs are used as input to a deep learning model and is further refined with the Dolph-Tschebyscheff distribution. Microstrip antennas we use it, and why we use it is because it's easy to implement some algorithms with this, and these antennas used as in aircraft and satellite communication systems and also radars. Most studies in the literature, we investigated that a lot of models such as genetic algorithms, deep learning, and multilayer perceptron use it for designing them, and increasingly use it deep learning techniques. Here is our microstrip antenna structure. Here we use it the width, length, and height of the antennas, and also operating frequency. We use it. Our equations are in here. We also implemented this into our algorithms. And here's the Dolph-Tschebyscheff distribution. Dolph-Tschebyscheff distribution comes from the polynomials of Dolph-Tschebyscheff. Here we can use cos mu, while m is 0, this equals to 1, while m is 1, this equals to cos u, and then this gives the further equation is here. Now, here we can see that if we know last one order of the polynomial and the last two of the polynomial, we can calculate the next polynomial, and we also implement this to our array factor of the antenna. And here is the genetic algorithm chromosome. Here we use 32-bit chromosome. We implement the specifications of the antenna in this chromosome. 4 bits for element count, 5 bits width, 5 bits length, 7 bits spacings, and 10 bits to height. And also 1 bit is, don't use it 1 bit because of the redundancy, such as if we need new bit, we can use this to length, for example, or height. And here is the algorithm flowchart. Firstly, we generate the initial population. This initial population we select randomly. And if this population satisfies our fitness function, it directly goes to new generation. And if it is not satisfied, we make crossover and mutation operations to it and generate the new generation. If the finishing criteria satisfied, it gives our result. And also, we will use this result in the deep learning application. Here is the deep learning application. We firstly make a decision about how many layers we use in our application. And also MCE is the key operator for us. We set a preparation with the same data set, and we tried number of layers from 1 to 20. It gives the best results at the 5. And also we used 5 layers in the application. And here is the architecture of our deep learning model. It has 5 input and 5 different input layers and 5 different neurons, and every layer we use it 520 neurons. And in our model block diagram, we use a data set generated from genetic algorithms, and we trained them. 30% is used for training and 20% used for testing. Our deep learning model building and evaluate is the model suitable. If there was analyze errors, again we train it, use it for, and the test data is used here. 20% of the data used for testing here. And 1,000 epochs we used. Here is again a feedback mechanism. Using this mechanism, again we training process again used here. And here is the final diagram. Here is the first part of this diagram is genetic algorithms part. Outputs of the genetic algorithms used as input of deep learning application. And out of the deep learning application, we use Dolph-Tschebyscheff distribution here. And here is the result. Here is a new array structure we get from this simulation. The frequency, operating frequency is 28 gigahertz. It is Ka band satellite frequency. Antenna model is microstrip patch. Distribution is Dolph-Tschebyscheff. Number of elements 4. Spacing between the elements is here, and other properties is here. And here is the radiation pattern of this structure. We show that blue one is uniform array. Orange one is only GA part, and the green part is GA plus deep learning part. In deep learning, we see that the small parts of this radiation pattern, side lobes are never been in the green part. Green part is better than the orange one. We compared these models in a radiation pattern. And also we know that in our conference, we see that again, these applications are also about antenna arrays. And this proposed model is a solution for that. And our next study will be an antenna about this model again. Thank you for your
Okay, somebody has any question? He was very fast, you know. You have 5 minutes left. And we have plenty of questions, you know. I think we have a right to go into deep, you know, and ask him, you know.
Talking about the output layer of your deep neural network, can you go back there?
Here is, or
Yes,
this one.
yes.
Okay.
What's your output there? Because I imagined that you were fine-tuning the initial parameters and you would have 5 output values, but I just see 1.
Yes. Our output value is here.
Okay, so in this...
Yes. Here. Here is a set of antenna array. And again, here is like this. And we use this output in Dolph-Tschebyscheff distribution again. For example, the output was, for example, gigahertz is different, for example, or number of elements is this, and we apply it Dolph-Tschebyscheff distribution. Here is integrated 3 different parts. Also, this question is good.
Okay, thank you. It was just the design at the end that got me confused. I understood now.
Okay. In this case, it's my turn. Can you go to the next slide? Here. You use number of element 4. Can you tell me the antenna gain?
What?
Antenna gain.
Antenna gain?
Yeah, because you have only 4 elements, the satellites are far away.
Yes.
And you told me, you can communicate.
Yes.
And even, worse, because you have 28 gig.
Mm-hmm.
So, the atmosphere
Mm-hmm.
will reduce your signal level
Yes.
strongly. So, I'm interested in how do you want to use the 4-element array in 28 gig for satellite communication?
Yes, this structure is only transmitter side, not about the satellite part.
Yeah, but it is a ground. You have to reach,
Yes, it has a gain. We calculated it, maybe nearly 80%, maybe.
But then, the gain is dB. How many dB you have?
dB.
Yeah, you have to reach, you have a phase equation to communicate. This is a transmitter, this is a receiver, they are far away to each other. They have a signal degradation.
Yes.
The other issue is, if you said to me, because if you are you are a PhD student, and if you have a tricky question, you have to say, yeah, I have a very low gain here. However, my transmitter is very powerful. I transmitting megawatts. Okay, and I can accept. Except you have a microchip antenna, and the microchip antenna not able to manage this power. So maybe it makes sense to increase the number of elements and calculate also the gain, and put the equation. Okay?
Okay.
I think, this is one of the stuff. Somebody else have some other question? And like a PhD student, nothing to do, out of business. But if you go one slide more, it's perfect. Next one. See? All of the presentation, as you can see from the following presentation, you not have to use, all kind of conclusion. It's not a conclusion. I have a reading training course, or something. It is, you have to put, my finding, 1, 2. This is and please take away. This is a key. You have plenty of new findings, the algorithm, okay. And you need right now challenges, because when you go for defense, you also have problem. And that's exactly the same at the beginning. What I want to achieve, what are the tools, what, why, and how. Okay? That's only for advice and nothing special. Okay, thank you very much, Because you serve it, you pay for the conference and you can get and bring something home. And we have the last presentation from today. Our distinguished professor from Serbia, Darden, will be on the improving the operation of the distributed network by optimal setting and sizing the photovoltaic battery energy storage system. This is the multiply authors here. And I'm looking forward to see, this presentation. Here, and, I think, Darden, you have, the ball and you can start your presentation.
Dear Chairman, thank you for this introduction. And I will present this paper in front of my co-authors. Just to find this option of full screens here. Somewhat. Okay, thank you. Okay, the first 2 authors comes from the Faculty of Electronic Engineering, University of Niš, and the third and fourth authors come from the Faculty of Technical Sciences, University of Pristina and Kosovska Mitrovica. Both universities are from Serbia. On this first slide, we can see some basic bullets related to renewables and to this paper. On the upper right corner, you can see one PV plant, And in this paper, this PV plant will be treated as a PV generator. And in the bottom right angle, you can see one battery energy storage, which be treated like BS unit. Altogether, in combination, I will call them like PV BS system. Also, we know that each power system is composed of transmission part and some distribution networks. Voltage profile and reducing power losses in each of these distribution networks contributes to, how to say, quality of electrical supply in one whole electric power systems. These bullets are prepared also. This presentation is prepared by my PhD student. This is not of high quality, but what to do? I will try to explain what we did. You can see too much text is on the introduction slide. This paper proposes an updated two-step approach to improve the operation of a distribution network through the optimal siting and sizing of 1, 2, or 3 systems. I said previously we will treat it as system one combination of PV plant and battery energy storage unit. And what we did, we compared these 3 cases to the one benchmark radial network IEEE 33 test system. And the main finding of this research is that if we increase number of these systems, 4 and more do not contribute to the voltage profile and to reduction of power losses in the considered PV, in considered distribution radial network. The improvement of distribution network includes the reduction of power losses and improvement of voltage profile, I said, and this was done in 2 steps. In first step, we made optimal siting and found optimal power flow in the considered distribution network. And in the second step, we made sizing of these PV BIS systems. And you can see from the last bullet that we considered IEEE 33 bus test radial distribution system, and our findings show that optimal locations for all these systems were on the main 2 buses that were also the longest 2 in this considered system. Optimization problem formulation is given on this slide. I will not go in details about them, but I will say also in this problem, like the yesterday's one, is non-linear with a significant number of constraints. For example, it is important to say some words about control variables in this problem. They are locations and every hour powers of PV-based system, and dependent variables are individual powers of PV generators and battery energy system units. States of charge of BESS units, the current flowing through the distribution lines, and node voltages of the distribution network. These formulas given on this slide represent some constraints used appearing in this model. I, of course, will not go in details about them. The first one is related to the BESS units, and their states of charge and discharge. And the last one, the last two, one is related to active powers, and the last one is related to reactive powers in this system. Criterion function is defined in this on this slide, and some details explaining what we did can be found here. For example, some formulas shows how we calculated daily average daily power losses and the voltage quality index, and depending on them, we considered locations that is good or is not good to incorporate these PV-based systems. Solving the optimization problem, this optimization problem is made with two meta-heuristic methods. Particles form optimization is used, and wild horse optimization algorithm. They two are combined, and we can see this, the second one, the wild horse optimization, is a relatively novel optimization method, and this is one of contributions of this paper. These two formulas are used based on them, on their values, the power loss sensitivity factor and voltage quality sensitivity factor are used for analyzing places in the IEEE 33 bus system for incorporation of these systems. You can see on this slide some basic information about particle swarm optimization. Of course, I will not go in details. On the next one is also are presented some basic information related to wild horse optimization, and are described the 5 steps of it. And now what is presented on this slide, the optimal sizing of PV-based system that should be connected to a distribution network corresponds to the minimum size of this system that can inject the required amount of power into distribution network obtained by the optimization method. The optimal sizing of PV-based system is determined from the iterative process. The iterative process uses the required optimal powers of the PV-based system from the first step of the approach, the solar irradiance diagram, the efficiency and desired energy increment of the base unit to determine the maximum power of PV generator using the given equation on this slide. The periods and some other parameters appearing in this equation are defined also at the end of slide. And now we have a presentation of our PV-based system, composed, as I said previously, from one PV generator and one base unit. And P represents connecting point to the node, to the distribution network. Also you can see some formulas on this slide, and what is the objective of this optimization method is defined here. This slide shows the flow chart of the proposed approach. And also you can see what I said previously, 2 steps: finding optimal sites for these PV-based units, and finding maximum powers of PV generators and storage, battery energy storage. This is explained, but some explanation of this diagram need a lot of time. Of course, everything related to metaheuristics need tables. You, chairman, don't like tables, but in this presentation has some of them. But what to do? Yeah. Yeah. On this slide, we can see this radial distribution network considered in this particular study. This is radial, and you can see nodes from 0 to 17, and this one from 25 to 32 second nodes that are two buses. There are positions for incorporation, connection of PV BESS units. That means in the first step, we eliminate by calculation some of these nodes. For example, nodes from 18 to 21st are eliminated immediately. Also, the branch consisted of 3 nodes, 22, 23, and 24 is eliminated. And from these two, the longest in the network, also some of them are eliminated in the first step of calculation. And after that, we got some positions convenient for connection of PV BESS systems. And they represent probably optimal positions for these systems. And what was interesting, first step, that means sighting of these systems gave and optimal power flow in this radial distribution network. And in the second step, using this algorithm shown previously on the flow chart, we are searching for maximum, that means optimal values of powers of PV generator and battery energy storage units. Of course, I forgot to say that we considered three different load profiles, marked like first, second, and third, and also paper considered this distribution network without PV BESS systems, and with 1, with 2, and with 3. For 4 and more of them, it is found that no improvement of voltage profile and no significant reduction of power losses in the system. And that was the reason because we didn't consider the 4, 5, and more, these PV BESS systems. Now tables, results. The table 1 is the simplest one with low amount of data, and this table shows average daily power losses and the voltage quality index for the distribution network for the case before connecting PV BESS systems to the distribution network for all 3 daily load profiles. Table 2 outlines the results obtained for the case after connecting PV BESS systems to the distribution network. I think just one system is connected and shows all performance parameters obtained after application of this approach shown previously in the flow chart. The next slide shows tables 3 and tables 4 results after connecting 2 and 3 PV BESS systems to the same distribution network. And this results shows what's happened after the connection of two systems, and after three systems to the considered radial distribution network. On this slide, we can see results related to the average daily power losses in the paths, that means branches of the distribution network without and with 1, 2, and 3 PV-based systems. On the second diagram, we have voltage profiles of the considered distribution network without and with also 1, 2, and 3 PV-based systems. Some differences exist between these diagrams, and on this slide we can see some average 1 hour powers of PV-based system, optimal powers, PV generator, and battery energy storage unit obtained for first, second, and third daily load profiles. What is interesting here to show, for example, PV generator follows solar irradiance, and load profile follows PV-based system power, and this repeats for all three load profiles. This slide shows a state of the charge for the best unit. For the ideal case, then efficiency is 100% and zero increment in the stored energy. The second diagram shows state of the charge for best unit for the third load profile and different efficiencies and increments, and some differences exist. Also, this slide shows average 1 hour powers of PV-based systems, again optimal solutions, and conclusions at the end. What is the main thing of this study? Obtained results showed that the connection of such PV-based systems to the distribution network can improve its overall performance parameters regardless of the shape of the load profile, and that level of improvement increases as the number of connected PV-based systems rises, but not higher not greater than 4 systems. It was found that only the nodes located along to the main longest branches in the considered distribution network can optimal sites to connect these systems, and that was found based on the indexes. The iterative method used in the second step of the proposed approach proves to be efficient in sizing elements of PV-based systems. It was observed that the sizing of PV generator in the PV-based system is most affected by the average load power, and that the sizing of base unit depends mostly on the matching between the load diagram and the power of PV generator. For the same level of the improvement in the operation of distribution network, both the decrease in efficiency and increase in the amount of energy stored in the battery energy storage unit during the operation increases the sizes of PV generator and this storage unit. This study showed that the required size of PV-based system is larger in the case where the priority is given to the improvement of the voltage profile than in the case where the reduction of power losses was priority. Sorry. Thank you for your attention.
Okay, Danan, thank you very much.
Questions?
Unfortunately, you know, your time is completely up. Due to this, I suggest that, we have a coffee break right now. And all of the question, what you want to increase, you think the coffee break, it will be much more efficient. I will ask you to come back 3:45, okay? The next section is started 3:45. Thank you again.
Thank you very much, Chairman, for your patience.